Hey guys, and welcome to the Gravity Simulator. I'm going to just show you some things and I want you to think about it, and then once we're done with this video, you will be able to go and play in the simulator yourself. So the first thing I'm going to do is I'm just going to hit build. Alright, so you get this lovely grid. So we're going to play with some planets. So these are actually, let's see, a star, and I'm gonna edit. So that one has a mass of 500, and I'm gonna put it right here. I'm just gonna show you how gravity is affected. So this one has a mass of 5,000, and I'm gonna say 1, 2, 3. So 1, 2. So they're both equal distance from the very center line. So I just want you to sit and observe and see what happens. So you see that slowly they are being pulled towards each other about the same rate, same distance, and they hit in the middle at the same time. And then they go almost to the same spot they were, and then they're going to be pulled back towards each other. They are pulling equally because they are equal in mass and distance. So let me restart this. And let's do star, same spot, 5,000 mass. And then let me change this to say 1,000. Okay, we're gonna put it at the same spot. So there's center, 1, 2, 3. What do you think's gonna happen? So if they're the same size, they're coming at each other at the same speed, same distance. What do you think's gonna happen with this one? So let me place it and let's see if your guesses are right. So as we see, which star is moving the most and why? Why is the smaller mass star moving more than the larger mass star? So gravity has to do with the different masses. So think of it, the bigger the mass, the stronger the pull. And because the red star has more mass, it has a stronger pull on the smaller green star. So that is why the green star is moving more. They both have a gravitational pull towards each other. It is just the smaller the mass, the more pull towards the larger mass. So let's go ahead and get rid of this one again. Okay. Alright, so the next thing I'm going to do is I went ahead and put a sun or a star that feels no gravity in the very middle. And just to double check, there's a button that says center right there, and you can put it in the center. So I'm going to choose some space dust, massless space dust. And I just want you to observe what I'm going to do now. Alright, so the question is, does distance away from the bigger mass, does the distance have a effect on how long it takes for the pull to affect it, or how much of a pull is affected? So let's say I have this space dust right here, and I just kind of trickle it. It goes quickly into the center of that that sun. But if I put it here, it takes a little bit for those the space dust to go towards the sun. So the further away something is, the less the pull of gravity is. So there's two things that affect the pull of gravity, and that is the mass of the object and the distance of the object. So let me put some planets and put them into orbit. And these are the same size, same mass. I'm going to try to put them in similar orbits. And the planets bounced off each other, so that did not work the way we wanted it to. So we're just going to go ahead and delete. And we're going to put a sun, well, we're going to put a star. That's 1,000. Okay, we're going to put it in the middle, so a sun, because the sun is a star. And this one has effects to gravity. So then I'm going to put the mass of this to be 100. And it is tiny. So I'm going to make an orbit here close to it. I'm going to put another one right here. And I'm going to put the orbit away from it. So the distance away is further, so it's going to get further. And then you'll see that there is a pull. Even though that sun is massive, there's still a slight pull. So what we're going to do is, like I said, the main thing that we've talked about is that mass and distance are the two things that affect the pull of gravity. Everything has a pull, but the bigger the mass, the more of a pull. And then the closer an object is, the more the pull is. So we will let you kind of play with this demonstration at the end of class. So let's talk a little bit about it.